The Earth we stand on today did not exist when the Sun was born. It was built, piece by piece, from cosmic dust, rock, and fire. For hundreds of millions of years, the solar system was a place of chaos collisions, explosions, and molten worlds. From that chaos, one planet emerged. This is the true story of how Earth came to be, around 4.6 billion years ago. Gravity pulled gas and dust from an ancient molecular cloud into a swirling disk, the solar nebula. At its center, immense pressure and temperature ignited nuclear fusion, giving birth to the Sun. In the outer disk, tiny grains of rock and ice collided and stuck together, a process called accretion. Over millions of years, these fragments grew into larger and larger bodies, called planetesimals, the fundamental building blocks of planets. Through countless collisions, one of these worlds grew massive enough to become the proto-Earth, a young, superheated sphere of rock and metal. As the young solar system began to stabilize, the era of giant impacts was not yet over. Protoplanets still roamed their orbits, and collisions were frequent and violent. One of these bodies, a world about the size of Mars that scientists now call Theia, was on a collision course with our own. It struck the early Earth with immense, unimaginable force. High-speed impact simulations show that part of Earth's mantle and most of their outer layers were vaporized and thrown into orbit around our planet. Within just a few months, gravity began to pull this superheated ring of debris together. It clumped and coalesced, forming our moon. The collision did more than just create a satellite. It tilted Earth's axis, giving us our seasons, and set the initial length of its day. The evidence for this dramatic event isn't just in computer models, it's written in the rocks. Samples brought back from the moon have a chemical fingerprint, specifically their oxygen and titanium isotopes, that is nearly identical to rocks on Earth, a clear sign of their shared origin. After the giant impact, Earth's surface was unrecognizably global ocean of magma over 100 kilometers deep. For millions of years, our planet glowed red hot, but as it slowly radiated its heat into space, the surface began to cool and solidify. Intense volcanic activity released vast amounts of trapped gases, water vapor, carbon dioxide, nitrogen, and sulfur compounds. These gases formed the planet's first atmosphere. It was dense, toxic, and utterly unbreathable, but it was crucial for Earth's evolution. As the crust hardened, the water vapor in the thick atmosphere began to condense. It started to rain, and it didn't stop for millions of years. This relentless downpour filled the basins and lowlands, and the first oceans began to collect, eventually covering most of the planet's surface. By about 4.3 billion years ago, Earth's surface had finally stabilized. Its molten crust had turned to solid rock, and the oceans of liquid water were permanent features. We know this thanks to tiny, incredibly resilient crystals called zircons, found preserved in ancient rocks in Australia. These microscopic time capsules contain isotopic evidence of liquid water. proving that our planet became habitable surprisingly early in its history. Although life had not yet begun, all the essential ingredients were now in place. A stable source of liquid water, a rich supply of carbon-based molecules, energy from the sun and the planet's core, and a vast expanse of time. The stage was set for the next incredible chapter in our planet's story. Forged by impact, shaped by fire, and cooled by water, Earth became the only known planet to host life. Its long and violent history is written in every grain of sand, every drop of water, and every breath of air we take. This remarkable journey from a chaotic disk of dust to a living world is our own origin story. Thanks for watching. If you enjoyed this journey through time, don't forget to like, subscribe, and hit the bell to join us for our next episode.